Okay, so this is a big slide. So this is where we're going to talk about all of these different vaccine types. And the thing that you want to understand here is you want to know which type of vaccine falls into which category. And there's a lot of different mnemonics here on to try to understand, okay, well, where does varicella fall, or where does, the BCG or smallpox vaccine fall? And the thing that I want to call your attention to, though, when you start to go through some of these mnemonics, it's really easy to get the different vaccines confused. So what I like to do is I like to look at some of the examples where there's only one or two major examples to understand. And you'll see when you look at the live attenuated, there's a lot more examples just in general that tend to fall in this category. So I try not to necessarily, like if I'm just trying to memorize these, I try not to necessarily start here memorizing all of these. I'll start with something like my subunit, polysaccharide conjugated activated, and just know, okay, these are the big three here. This is the big polysaccharide, etc. And then, anything that doesn't fall in these kind of smaller example buckets, then you'll know that that's probably going to be in the live attenuated. But even what's more important than that is understanding the comparisons, right? So you have to know intranasal influenza versus intramuscular. You have to know Sabin versus Salk. These are the really big things that you absolutely want to be familiar with. And we'll talk about all of this as we go through it. But we're going to do this in building blocks. So I like having everything on one slide so you can just quickly compare it. But we'll do this in separate videos because it's a lot of material. So without further ado, let's start talking about the live attenuated vaccines. When we're talking about live attenuated vaccines, we're basically talking about taking a live pathogen, right? So if you want to use the example of a virus, okay, or you can say a bacteria, let's just say a virus, okay? So I'm just going to draw some virus here. We're actually taking this virus, right? And we're putting this virus into our patient. Okay, so we're taking a virus and we're putting it into our patient. And you might say, well, that sounds really bad. We're basically just kind of infecting this patient. Now, the thing that's different though, if the virus normally uses, some factor to get into the cells, okay, so we'll just say this is its, this is related to its pathogenicity. Okay, so if it has something that's related to its pathogenicity that allows it to replicate, that allows it to infect cells potentially, what we're going to try to do is we're going to try to knock out the things that are really increasing the pathogenicity of this organism. Now, that's not to say that it can't replicate, right? They're live pathogens. They can still replicate. They're just less pathogenic, okay, and tend not to cause disease. But they're still going to have the antigens on their surface that we need to generate antibodies, right? So once we're given this live pathogen that just doesn't tend to be as pathogenic because we've made some modifications to it, then this patient will then have that live pathogen replicating and then will produce antibodies against this pathogen. Now, the key thing here is, remember, you're adding in here a live pathogen. And what step one likes you to know is to know what kind of response are you going to generate. And this is where you really have to think about your pathways here. So just going back to what we've been talking about this whole time, right? So here's our dendritic cell. Okay, and we've gone through this a few times now. Now remember, a dendritic cell is going to have an MHC1 receptor on it, right? It's going to have an MHC1, and it's also going to have an MHC2. Okay, now most cells in our body, like we talked about, are going to have MHC1, most of the nucleated cells, if not all of them, but the MHC2 receptor is only going to be present on antigen-presenting cells. Since a dendritic cell is an antigen-presenting cell, it's going to have both of these receptors, right? Now, if I have some live pathogen that I just put in the body, a couple things can happen. The first thing that can happen is this dendritic cell can digest this pathogen. Okay, so you can have phagocytosis of this pathogen. Now, if that happens, the dendritic cell is going to present this pathogen that we just digested. It's going to present it on MHC2, right? It's going to present that pathogen or that antigen from the pathogen on MHC2. And we already know what this is going to do. MHC2 is going to trigger my T helper 1 cells, right? My CD4 positive cells, right? Rule of eights. So CD4 positive cells are then going to bind to that MHC2 receptor using their T cell receptor and their CD4 positive co-receptor. And this whole process is going to lead to these T cells eventually activating B cells using CD40 ligand, right? We talked about all of this in the previous video. So if you're not familiar with this, go back, watch those videos. We go into this in great detail. And then we're going to have the CD40 ligand binding also. That's going to allow for class switching. And then these B cells will then become activated, right? And they'll go on to become plasma cells. Okay, so they'll go on to become plasma cells. And a plasma cell is essentially an antibody factory. And so now we're going to produce a bunch of antibodies to this antigen. Okay, that's pretty much the whole process. And that's going to be very consistent with what we see across the board. Now, remember what I said here. There's something really important. We're going to have CD40 ligand class switching occurring when this T cell uses this binding to a B cell. Okay, so remember, that's important. That causes class switching. Now, when you say class switching, what am I talking about when I say class switching? When I say class switching, I'm talking about taking IgM antibodies and turning them into a different heavy chain, right? So either IgG, IgA, IgE. Now, when we're talking about a memory response, we're primarily talking about IgG antibodies, especially in these simple kind of straightforward board questions. So when I say that there's T cells, right, these helper T cells go on to activate these B cells and they have class switching, what we would expect to see, right, is a strong immune response from this pathogen because we're going to generate IgG antibodies because we had class switching. That's an important piece to remember here, okay? So that's the first thing. You're going to get a good immune response because you're generating humoral IgG antibodies. You're going to have a memory response because you're involving T cells that are activating B cells, and those B cells are going to go on to have some memory B cells and also some memory T cells, and you're going to have these plasma cells pumping out IgG antibodies. The other part of this, let's go back a second. We said, okay, we went down this MHC2 pathway, and that MHC2 pathway allowed me to generate a very strong humoral response that involved class switching because we had T cell activation. What about if we go down the other road? Is it possible that this dendritic cell would present this antigen on MHC class 1? Okay, is it possible? Well, what would have to happen? Well, instead of the dendritic cell phagocytosing this pathogen, let's say this is a virus, right? Instead, maybe this virus infects this dendritic cell. Okay, so maybe instead of the dendritic cell phagocytosing it, the virus actually infects the dendritic cell. Now, if it does that, right, if this virus starts to put its viral material in this dendritic cell, we talked about this when we talked about these MHC receptors, this material is going to get broken down, put in the rough endoplasmic reticulum, and it's going to get sent up to this MHC1 receptor, okay? So now this is on MHC1. So what's MHC1 going to bind to? Well, if it's going to bind to anything, it's going to bind to cytotoxic CD8 positive killer T cells, right? So these again are T cells, but they're CD8 positive T cells. And again, the T cell receptor and the CD8 positive co-receptor are going to bind to this MHC1, and then this cell, realizing that there's something not normal here, right? Something that's not a self-antigen here, there's going to be perforins and other enzymes that are released to destroy this dendritic cell. And we're going to start to get some memory response from the T cells. Okay, so you're going to get a cellular mediated response. Remember, when you have these CD8 positive T cells destroying these dendritic cells or any cells in the body, that's going to be a cell mediated process. And so we say there's a cellular response or a cell mediated response and a humoral response. You can actually get both from a dendritic cell, right? Because the dendritic cell can phagocytose this, presented in MHC class 2, or the dendritic cell can actually get infected with this and then presented on MHC1 like a normal cell would. And because of this, we can get a cellular or cell-mediated response. Okay, so you can get a cellular response, and we can also get a humoral response. So we can get both because we gave this patient a vaccine that had a live pathogen. This patient shouldn't get sick, right, when they get a varicella vaccine or when they get a yellow fever vaccine, but they can get sick, right, because some of these pathogens can actually alter their virulence factors, right? This pathogen can alter some of these virulence factors, and it can actually then become pathogenic. Okay, so it can become pathogenic potentially, but that's not extremely likely. Now, where are we concerned about these pathogens potentially increasing their pathogenicity? We're primarily concerned about that in patients that are immunocompromised, right? Patients that don't have a good immune system are going to have a tough time responding to organisms that have acquisition of new virulence factors. Okay, now what patients are we going to be really concerned about in this category of immunocompromised states? Number one is infants. Now, most infants, and these are children younger than a year of age, most of them are not going to be getting these live attenuated vaccines. There's one exception to that, and that's the rotavirus vaccine. So the rotavirus vaccine is actually designed to be given usually around the first 6 weeks of life. Okay, there are some contraindications to the rotavirus vaccine, things like intussusception or history of GI tract malformations like a Meckel diverticulum. And this is more of a step 2 thing, but the reason for that is because you can have lymphoid hyperplasia in the Peyer's patches and you can end up with intussusception, right? Because this is generating an immune response, and so you can get lymphoid hyperplasia in infants. The point is, though, is that if you're going to remember, there's one exception exception to live attenuated vaccines. It's the rotavirus vaccine in infants. In the elderly population, we also will tend to start to avoid some of the more live attenuated vaccines. Pregnant females, same thing. These are kind of your big three. And then always remember transplant patients that were giving them immunosuppressive medications, or patients that have AIDS. Okay, so a patient that has HIV, this comes up pretty frequently. Now, let's say that this patient, you have to decide, hey, I have a patient here that has HIV. Do I give them their, varicella vaccine, for example, if they haven't had it? And how do you make that decision? Well, you have to look at the CD4 count. So if the CD4 count is greater than 200, right, which is usually the cutoff here, when we're talking about, an opportunistic pneumonia versus a normal pneumonia, we're going to look at the CD4 count, right? If you have a low CD4 count, you're significantly predisposed to opportunistic infections. If you have a normal CD4 count, even though you have HIV, it doesn't necessarily mean that you would have an opportunistic infection. The same is true here. You're not really considered to be extremely immunocompromised if you have a CD4 count greater than 200. However, if the CD4 count is less than 200, especially if it's significantly less than 200, these patients should not be getting live attenuated vaccines. However, the patients that have CD4 counts greater than 200, that's usually going to be okay to give them, especially in a board question. Okay, and the big vaccines here, like I said, you do have to commit some of these to memory. Varicella and MMR are probably the two highest yield, but you do frequently get questions where you have to distinguish different types of vaccines. So I would be familiar with the fact that the intranasal influenza vaccine is a live attenuated vaccine, whereas the intramuscular influenza vaccine is an inactivated or killed vaccine. In one case, you're giving them a live influenza strain. In the other case, it's a killed influenza strain. And we'll talk about that in a moment. And you're not really going to see intranasal influenza being given much in the United States. You'll primarily see the intramuscular variant. And then also remember that polio vaccines, there's two types. So you have Sabin and Salk. Okay, remember the Sabin is the live attenuated form, and the killed form is the Salk. And the way that I kind of remember that, okay, so the last letter is K, and these are going to be completely inactivated vaccines. And we'll talk about this in a minute. And so I remember that K for killed. So this is going to be a killed organism that we're giving the patient. And I always look at that last letter to distinguish the two. So K for killed. That's my easy way of remembering that. But you do have to distinguish these very frequently, so I would be familiar with them. And then BCG for tuberculosis, we'll talk about that probably in a future video. And then we also have smallpox here as well. But the big one here, I would say, especially for the US, know your varicella, MMR, rotavirus. It's going to be the exception in infants. And then for travelers, you'll see yellow fever occasionally. Not really going to give a whole lot of intranasal influenza in the US, or the polio Sabin for that matter. And in the next video, we'll talk about some of the other variants here.